This is 34A for game design. Just examples and rudimentary concepts, really, over simple principles in game design that you should be aware of, like actors or objects rather. Objects are actors within Stencil, and therefore the core of our game, since the majority of our code will go into the actors. Actors are a necessity to make our code even work, with actors taking many different forms, making objects a fairly versatile tool for our games. Without actors, not only would playing our games prove boring, but would make it incredibly difficult to play test, let alone play them. And if all objects were uniform, our game would lack the uniqueness needed to innovate and inspire future developers the same way our actors' aesthetics are based upon those that came before us by the designs we make. So having actors not only allows our game to function on a visual level at least, but helps them to stand out and stay in the minds of players, which I believe to be an integral part of art and culture as a whole. For instance, Inside by Playdead, despite my personal thoughts of it, has many moments I can still recall to striking imagery of a dystopian world with the few people you see chasing and trying to kill you. The world is covered in so much haze and uncertainty that I'm still not sure on the overall message of the game. Visually, it's nothing special if you take it standalone. A minimalistic style, yet it's how the objects are used to create mystery, to tell a story simply by environment. This change and frankly boundary pushing way of storytelling, though small in movement, has garnered a small community of critics not wanting to beat down developers, but like poetry, a group looking for any hidden meanings and metaphors within games, finally giving our games the respect of art. What remains of Edith and Finch you could say is the spiritual successor to Inside, whether by coincidence or intentional, taking the environmental storytelling and seamlessly transforming it into a 3D space. Therefore, the importance of actors lie in the ideas they inspire within our own minds, as seen in the example of Inside passing the torch over to what remains of Edith and Finch, being the core of not only environmental storytelling, but how we display what are good and bad actors to touch or follow. So, as even though we need actors to input our code into, at least I use it to signify the effects of actors. Also, because I'm bad at art. Now, in summary, there, just talking simple about objects, actors, just literally the images and the instances that you can see on screen of said actors. Fairly simple concept. You could go in a couple of other ways, I could imagine, but personally, I would much rather stick with the environmental storytelling aspects. You should probably use your own example for this one. Most people have played a lot of games. You can reference other source materials. I've never been one for environmental storytelling, even in big games though. Just off the top of the dome, I mean, Fallout New Vegas is definitely a great one up there if you ever thinking of it. Even newer Bethesda ones like Skyrim do have instances of environmental storytelling, but fairly simple concept. Not reinventing the wheel here, are we? But needed and necessary, essentially speaking, for games. Classes. Classes, i.e., the groups of which we set collisions for within our different objects, allow us to vary certain collision rules within the code to great effect, as we can add a good deal of object types, collectibles, moving platforms, bouncy tiles, enemies, breakable blocks, and so on. It also lets us simplify code, as otherwise we would, for instance, say, make a behavior that when touching a specific object broadcasts death within the behavior to either hide or kill the actor, which, regardless of workaround, slows the pace of our game development. Here is an instance of a class in use and what they can do, which I imagine you can make out what it does. Now, think about what it does. Now, think about how complicated it would be without classes. Now we have a better understanding of their uses. We can look at bigger games that have managed to work in many unique effects for its groups. One such is Terraria by Relogic, with lots of fun and interesting interactions such as the shimmer, the shiny purple liquid, that causes the player starting knowing all collisions as long as they are in the liquid, or the golf mechanics with normal tires tiles now being bouncy for the ball, the stickiness of honey blocks, catching animals in a net, fishing in different biomes, the tower defense type army, ooh, where you can spawn turrets to protect a gem. There are countless times to Rare changes the script, so to speak, in order to add variety and memorability to the game. In my opinion, couldn't have been done without classes to change the rules of collisions to match the game's needs, helping to expand the replayability and reduce any fatigue or tedium built while playing by introducing new concepts. Therefore, the inclusion of classes in games helps to elevate the experience for players and developers alike. One, by simplifying any complex string of coding we might have to do in order to get the desired effect, while the former receives an enjoyable game filled with new concepts and approaches to design. Further pushing the boundaries of what games are able to do while simultaneously lowering the skill level required for upcoming developers interested in coding with such a simple yet deep mechanic. So, oh, whoa. Classes. Again, pretty simple stuff. Grouping. You know, actors, players, tiles, enemies, anything that you might add into your game at the very start. Those things would be groups. And then obviously you can change what effects they can do and what they can collide with, as seen on the left here, by enabling them with certain other groupings you might have added. Obviously, simple names. Make sure you can remember this stuff. And, yeah, that practically explains it all. Add tons of unique ways for them to interact with each other just by more complex statements, but this is sort of like the skeletal structure that makes up the game. I wouldn't really say, again, necessary, although it is useful. Instances. An instance is just a copy of an object being shown on screen, so multiple instances of an actor can appear at once since they're copies. So an instance is the moment the actor is printed on screen. Instances let us have reoccurring actors without having to duplicate actors or rewrite any code, therefore saving time that can be instead making entirely new actors. In most cases, instances would take the form of bad guys or collectibles, where you would need many instances of that actor as they repeat throughout the game. Meaning we can simply drag the actor from stencil onto our level and quickly create instances of our actor, making level design easier, or to create instances when, say, a player enters a region of an enemy. Bullet hells like Enter the Gungeon by Dodge Roll need many, many instances of bullet projectiles as shown, otherwise we would quickly find ourselves spending all our time copying out bullet actors. In Enter the Gungeon, as a roguelike, it heavily relies on the use of instances as the entire game has all its runes procedure generated. Whatever. Ironically, despite the main use of simplifying duplicating actors, it holds a special use, that is of adding or decreasing challenge. More instances of enemies and bullets makes for a harder game there. But the reverse would be increasing instances of the bullet shells in-game currency. How many gun types will appear, how many bullets those same guns shoot, the amount of tables, planks, shotgun shells, HP, etc., etc. Instances hold a great deal of control for the balancing of games. Deciding how much of any given actor should appear at any moment effectively designates a level of difficulty within the game, which Enter the Gungeon does near perfectly based on the two images. As daunting as the first may look, the game eases you into its mechanics with an easy room, like the second image shown, then slowly increasing the instances of enemies and bullets until you get something like image 1, which is still by no what? The game is most challenging. Oh fuck yeah. Therefore, instances are not only a tool to remove tedium or wasted time during game development, but add to the game experience by creating how many of a certain actor should be made, creating a sense of fairness and causing balance to the game in the most visible sense. So it could be argued that instances make the new one. I'm barely literate apparently. Whoa. In the most visual sense. So it could be argued that instances make games enjoyable, as without them we could be left with is games too hard or easy. Letting our medium to express ourselves more accessible to users so that our game can become widespread amongst players to fully see every idea we make. tripped up at the end there, but yeah, instances, creating copies of something, just another visual effect, you could say, of something you've already done before. It's repeating itself effectively. Instances. I mean, there's not much really add to this. If you wanted to write something like this, any bullet hell would really do. Honestly, there's so many examples, theories out there, but this is 34A. You probably want to stick to 2D examples if you have any more. Maybe something like Brotato if you ever played that. But yeah, instances. Events Events are what most would argue the most important part of games, as they make them even playable. This is because events are what a code relies on. They let us say when, how, where, what, and who to affect our objects, meaning events have a wide span of control that can take the form of a lot of things like inputs on the keyboard, receiving broadcasted messages, identifying collisions, even just true or false statements. On the left, you can see instances of events which are examples of way to code jumping or movement but have deeper uses, such as the set false statements for touching platform, which on a wider stage makes it so when players touch is moving platform, the game doesn't always think it's now on the platform, or the more than statement for force, which makes it so when players get a boost in the force, it resets the force. This code is just an example of my own personal code and how events can cause simple but also complex mechanics, making it very versatile. Another good example is in Vampire Survivors by Ponko, clearly showing many occurring events, not just collisions but movement of projectiles, enemies, the player, tracking in-game time and experience. You might look at this and feel overwhelmed by the sheer quantity of objects on screen, yet it starts so simple, few enemies and a single weapon, but by adding new events as time passes, new instances of items, enemies, projectiles, and volume increase. These effects are fundamental to the core gameplay loop of Vampire Survivors, in turn making events an integral part of game design. Continuation. In conclusion, events allow for the inclusion of core features but can also be expanded to welcome broader coding commands, acting as a sort of flour in a metaphorical cake. Anything complex or basic couldn't have been done without events, so every idea of game development could only stay in our head without events to further elaborate on what we want to change and by how much. Events. Really your bread and butter. Uh, you should already have a grasp on events by now. If you haven't had any work in Stencil, then you should start right now, honestly. For this, they aren't too hard to wrap your head around. A lot of them self-explanatory in title, easy enough to get your head around, to grasp, function. Some little things might trip you up, but quickly you'll realize it's just referring to first actor or the actor group that you were referring to here. In such instances, really, really basic, but again, they can be expanded on in such a wide way that it really just leaves you with an open ended of like infinite possibilities to really put into just form, I guess you could say, into a string of code that will work and function. And honestly, for events, you can use any example. If we're being completely honest with ourselves here, all games have events, as stated. All games will have to use events. They are integral, again, bread and butter. Not much you can really say to that. It really, really comes down to, I haven't said this yet, but most of the time should rather come down to the examples. You want to give a nice range of examples. Don't just stick to a certain genre of games. Make sure you've got all bases covered, effectively speaking. Data types, integers, floating points, and Boolean. Data types can take many forms with true and false statements. Boolean, text and numbers, whether they're illogical like pi, whole numbers, or vary between 2 points. So data types are just a statement or value for what a variable should be. Meaning what data types do is decide the amount of what we tell our code to do, such as when we program commands for numbered values for movement, it now controls the speed at which the object is moving, acting more so as the base to what we build for our games, as without values to go off of, everything would be imprecise and would make our game feel strange as there would be a lot of inconsistencies. As seen by my screenshots of code, there is a lot of data that needs to be set in order for the whole string to actually work. It requires a lot of data to be set, varying from integers, floating points, and Boolean statements to to summarize the entire blocks. We're saying essentially when touching launcher, player will be stuck to launcher until space is pressed, causing player to be launched in the direction of launcher. Data types make this possible as if we couldn't assign values to the position of objects or prove whether or not two objects collided. I wouldn't have been able to add such an interesting feature in my game titled Rush. Despite seeming as puzzling as solving for my binomials, the sequence is simple when you get down to it. In fact, the idea itself is one for one copied off of Donkey Kong Country by Nintendo in 1994, which since then games have come a very long way. So now I'll be showing a more modern example. Continuation. Oxygen Not Included by Clay Entertainment, also known as ONI, features many set data types, whether it's melting slash boiling points, and the reciprocal to that, the freezing slash condensation, specific heat capacity, radiation absorption factor, hardness of material. ONI is a great example in the use of data types with lots of moving pieces to puzzle together in order for it all to work. To the right of that information is an image displaying different gases in an area signified by colors. As you can see, they tend to link at different levels as they all have different weights to them. So as they diffuse, the rate is proportional to weight and pressure, aka the amount, which is more clearly seen in the image right of it, where the surrounding tiles are being damaged by the pressure, proving all materials, regardless if player made, are prone to breakage. Now, I may not have access to Oni's code, but I can make an estimated guess that such a complex physics game engine is made up of countless integers, such as for specific heat capacity, floating points, pressure for gases interchangeably swap kilos of said gas to each other, and Boolean statements such as whether a player is in oxygen and therefore can breathe. So, therefore, data types are valuable as they can provide a strong base for us to go off of and branch out into many unique and unseen before in-game simulations such as ONI, as well as simpler features going back to the launcher example, and therefore solidify data types as a versatile and needed part of game design. Data types. You didn't have to be this specific with it. This is if you want to go the extra step. If you want to bring up illogical numbers and if you're doing further maths, real and fake numbers, you can definitely go for it. I don't personally understand real numbers. I don't do further maths, but you can put it in there if you can manage it. I wouldn't be sure of the specifics of that, but you can definitely try for it. They definitely do appreciate having very focused points. So if you have any deep rooted knowledge into any subject, regardless of whether it has to do with game design, as long as you can make it fit into this, it'll count for something. And they do appreciate that. It makes for a much more interesting read through when you're going through it. It'll provide you with a lot more positive feedback than negative, and won't bore the hell out of your teacher and make them despise you. But as for data types, I mean, if you ever played like an idle game, data types could work. One I would suggest, but it comes up later in my own PowerPoint, it would be the idle spiral game. But thinking of examples is always going to be tough. You should, if you haven't, again, play vast genres of games. Make sure you have all bases covered, and so that you can just flip through like your Steam library or something, and then you can just pick out what you think would be a best fit for data types, which is exactly what I did. I spent maybe like an hour or two and came up with a long list of games for all of these points, and then I just went through them, and anything that I had to tweak out and maybe swap out different games for along the same genre as I went, because you realize that you're writing about something and it doesn't fit at all now because of the point you've made. It should be simple enough to go back in your library and just swap it out. So, yeah, data types. I feel like the main takeaway from this would be true or false statements. They're very useful, very simple, very just just more fun. I would be so sick to death if I had to put in one and zeros for equal to values as my true and false statements. Uh, you could definitely. I feel like you could go a lot more in on Boolean. I don't think I touched on that enough here, or specific any specific type of data. But again, it does ask for all three, so you make sure you do get all three down. Constants. Constants are values that will usually be set to one permanent value across the game, never changing, making it so we can use constant values for events that should always happen, such as the force at which a jump command pushes the player off the ground, speed for enemy movement, strength of gravity, bonus from coin/collectibles, and so on. In turn, creating a sense of balance and equity to our games, which could justify internally for players to continue pushing forward into our games. Personal examples in my game are for the enemy speed/position, where it has to stop, as well as the speed used to fire off an attack. However, things that can be constants could also be movement speed dependent on game, despite my use of speed setting itself to a random integer to move the player. Therefore, constants could theoretically be anything within a game. Take Poly Bridge by by Dry Cactus, where the stress of cars as well as the stress on your bridge is interchangeable. However, the values for which they can bear in terms of force are set. In each level, you are given a constant amount of cash that you have to work with using materials that have internal material strength values that are constants. To me, a constant is therefore a limitation to keep the game fair and balanced. Otherwise, if your bridges could hold an infinite amount of weight, there would be no challenge in Poly Bridge 2. No reason to keep playing, and ever to draw you back in to explore more of what the game has to offer, leading me to believe that constants are numbers that, just like in reality, bound our games together with rules and logic. And and as seen prospers in strategical games, whereas in more open-ended type games, constants can be hardly seen, such as exit the dungeon, making them more of a logic-bound tool for us to utilize rather than something we can endlessly fiddle about with, yet still a useful one. Constants, then. Yeah, this could have been a lot better looking at it. Uh, Ignore the formatting. I thought I did this a lot better. Apparently not. No wonder I got ducked down for it. Jesus Christ. No, but yeah, make sure you have this formatted all nicely. This is. I went for messy as a sort of charming point. Don't do that. It's not a charming point, apparently. You have to look very professional with these. Make sure you have a set font and coloring. And don't do whatever this is. Put them on like a separate slide or screenshots if you want. As long as you get it down in a neat way. Just don't do what I've done. That was a mistake on my part. But constants, yes. Could have been expanded upon. A deeper analysis, better evaluation. Again, no, as you can tell, analysis, and that's dependent on the game you chose. So I could have chosen a better game probably here, and I could have gone maybe a lot deeper into that. But at the same time, I was on a strict deadline. I don't know if any of you will be. Just make sure whatever you do is good enough. But as for the constant values, again, it's just a number that shouldn't really change across the game. Something that, as the name implies, would be a constant. We're still on to very simplistic concepts, I'd say. I think, if I remember correctly, actually, we should be delving into more deeper ones, complexity, rather. But it's pretty simple stuff. You could answer this without any knowledge to game design. You don't even need to do game design to answer this question. You will know what a constant is. At least I would hope you would. I don't need to tell you what it is or what it does. Local variables. Local variables, known as attributes within Stencil, act similarly to how we would use algebra and maths, making them a favorite tool of mine. However, in contrast with global variables, local ones act only within the object, which helps simplify our code. As for me, I'm creating lots of variables, and having a long list of global variables to scroll through every time drags out and lengthens the time to code. So local variables help to optimize our game, getting rid of any spaghetti code, which helps the readability of our code, letting us navigate through the strings, which decreases development time for our game. The main purpose is to hold values that will later be drawn from to use in a string of code. They can also take many forms like boolean, number, but also actor groups and collision shapes. Below we can see an instance at which technically two attributes are at play, since x of self is only accessed through the actor, telling the actor to move by x velocity and to change to x velocity when coordinates of self are more than 725 and less than 635. Another thing we could do is rewrite the code underneath the former example to simply swap the string to the player, which makes the variable escape the need to be global, which would help make the code more concise and shorten the list of global variables. In games, there are many examples of them using attributes. However, I believe nooo by Nolla Games extensively relies upon this, as everyone has its own unique feature and ability and magic to cast. I can only assume that within each spell is attributes that dictates the values and effect of each one that can be freely swapped around via the use of behaviors, making for quick, fast-paced combat, all the while enabling us to go back and easily fix any problems, as it would only be in one actor, and continue forward smoothly with our development. Continuation. To conclude attributes, they enable a vast variety of uniqueness game mechanics such as in the Nooo, but arguably more importantly allow us to find workarounds to traditional code, helping to explore new ideas and concepts. Sure, on the surface we can say yes, nooo uses attributes to have an expansive and dynamic range of spells. Rather, though, by making us think more about the optimization to remove unnecessary complexity, it causes us to think more deeply about what we put in our game and the wider effect. In my mind, this makes attributes a useful asset in our arsenal to further prod our brains and delve deeper into our imagination, causing us to find new workarounds that can straighten out our code, so to speak, or adding new mechanics. Could have been better. Again, uh, first of all, spaghetti code is a real term. You can put that in there. Maybe we'll get like a laugh out of your teacher. I don't know. Mine one's kind of chill, but the real term is just it literally just means the code's a mess and it's barely functional. If you wanted an example of a game, Eidolon has frequently been attributed spaghetti code. It is barely functional, but that is that. As for this here, uh, it's a bigger list. And speaking of lists, that was something I forgot to mention. Personally, our class hasn't covered lists even after we finished 34A, and apparently that's a year 2 topic, which I somehow feel doubtful in its expertise. There are no videos that I could find of lists, so you should just work on it yourself and try to figure it out from there. I'm sure you'll get a lot of bonus points and credit or whatever by doing so. They don't really seem too complicated. It's just you know, new thing to learn. Yeah, and that's always a hassle, so I understand. But pretty good example. Nice sub in with behaviors there. That definitely, pulling stuff like that with whatever you're coding into is definitely a good thing. I mean, the one you saw before here, that's a behavior. And behaviors, not fuck. Behaviors are always a nice thing to just tie into. Behaviors well, I wouldn't say they come up later. They don't come up in the PowerPoint, but within your own games, I'm very sure you'll be finding yourself using behaviors frequently if you ever plan to go into a more deeper level of game design. Global variables. Global variables or game attributes, as we know in Stencil, just like local variables, hold values within themselves that can be called out of later, and however, the difference here being that any object can call upon the value to alter it, offering a more narrow set of interchangeable values, yet despite that are often still more complex and versatile than local variables, meaning they are capable of offering deeper, more complex mechanics if used correctly, since all objects can access global variables. In this line here, this is actually an interesting line of code that you would see pop up a lot. Essentially, is what this does is this will push the actor towards the player. That's all it does. But what is more interesting is how it does that. The p of x and p of y is essentially drawing rather a straight line between you and the player from the coordinates, which has more interesting features like when you're drawing circles, because that just makes it so it's the radius of a circle. Or if you're doing anything related with triangles, that will be the hypotenuse of the triangle. Uh, not it probably won't be practical for something you will do, but it feels practical to me. I major in maths, if you couldn't tell by the binomials and the fucking algebra from before. But it's always worth having keeping in mind. Examples of global variables being utilized are for enemy pathfinding towards the player, when certain values need to travel between objects such as true or false statements, or just in general much larger equations. Though for a better representation of this fact, Brotato by Blobfish will be shown. Now, in Brotato, certain weapons that are of a select type can give bonuses to specific stats once enough of the type have been collected. Regardless, now it can be broadcasted, be a broadcasted statement in behavior. However, I think that would cause more trouble as it would act for the whole of the variable, whereas the global variable ensures that the value of the variable won't spiral out of control. This mechanic is what sets Brotato aside in the survival genre as a personal genre I dubbed after Vampire Survivors and the many poor imitations that follow it. Yeah, I digress. Putting it a set above its peers and has been used in other titles like God of Weapons by Archmage's Lab, thus proving that global variables contribute in the progression of the culture, but positively leaving deep impact, but not just within game development itself. Though at least my experience, global variables were a great gateway into more technical aspects of coding, but on players for as much as I enjoy Vampire Survivors, I prefer the gameplay of Potato infinitely more, even if the developers are scum, as it's simply the more customizable and therefore a playable game. Without a doubt, I think it's safe to say now global variables help young and even professional developers create memorable experiences and mechanics within our games, helping push the boundaries of what games can be. Global variables. I mean, you will always be using global variables. This was my first introduction to variables. I feel like this would be everyone's. Therefore, then when I started on Scratch, it was global variables. Then I moved on to broadcasting statements, but it was years since then when I moved on to the official course of game development, and I had forgotten all that stuff, and I immediately started with what I knew: global variables. So to me, this is always just kind of like my bread and butter. This is my personal bread and butter. I will always use variables, algebra. If you're bad at maths, this can get a little tricky. You might wanna ask help from high places, aka you wanna start praying. Uh, the teachers do tend to help. My personal teacher has a statement out right now for the next week. Any code you want done, you can just send it to him, and he will try to make it for you. Uh, I hope all your teachers can be just as kind. If not, yeah, you're just gonna have to work through this. Uh, what you could do here, I mean, you could do a lot better here. First of all, more examples. This one, this is a sad example. I have a lot of other examples. It's because I was going for a different one for each thing. I didn't want to reuse any of them, and I was on a very strict deadline, and I didn't have time to make a new existing thing for it. And this works just as well, in my opinion. But again, drawing back into what I said earlier actually, you could state that this is the radius or hypotenuse between the 2 points of, because whenever because soon you'll be drawing circles. Later on, you'll see that. I think it was in fuzzy logic, I believe, which will come up later, and uh, as proof, it will literally draw a circle, and then when it enters that point at which this is true, basically, it'll push you away, which proves that it is the radius. Yeah, you could definitely state that. that would be some free bonus points there, brownie points. Any other existing code you might have that uses global variables would be better. Just use more than this. Don't do just one of these. This was poor, poor, poor. Just everything on my part, especially with the grammar here. I mean, setting aside everything else, my grammar on these has just been terrible. I know I skimmed letters, but I didn't think it was this much. Syntax. Syntax is the order which our code goes through. So essentially, our strings are turned into a list that are then read off in that order, which therefore dictates our logic. As without proper order, our sentences wouldn't make sense. As dictates logics make order r. Yeah, I have to be looking at an older version of my thing. There's no way I said or. Okay. Order are proper sentences. Oh, notice how that sentence didn't make sense, or like any sense, despite its correct arrangement alphabetically, thus proving the way in which we order things controls their effect, so that we get the desired outcome by merely swapping the order. In summary, syntax is the layout for our code as it passes through logic gates to get the outcome we want. Syntax is important for any game, including mine. For instance, if we killed collectibles before we increased the score, that variable wouldn't go up as the actor would no longer exist to fully enact the string. Or for longer equations, if any one part swapped with another, the string would then give the incorrect value to our equation. For obvious reasons, it is suboptimal for us to be receiving incorrect data values, but a more gameplay focused lens on syntax is needed to show the full importance of it in turn. I believe a great example is Bubble Battle by Johann Grovier. I hope I'm saying that right. As the revival ability would cease function if the order was incorrect. But since the syntax is ordered correctly, it lets you duplicate yourself. Or in the grenade, if organized wrong, they would immediately explode and kill the player, which is counterintuitive as it's meant to be a power up. So syntax is in control over the fundamental rules and function of the game to ensure game mechanics are in proper working order. Its value cannot be undermined in that sense, but it's limited. It's more of a common sense thing using syntax. Bubble Battle was more of a rare instance where I created a new gameplay mechanic, but for most will be implemented even unintentionally, as it's more intuitive than not. It only makes sense, at least when I started, that code would follow the order you give it, and so could be why I don't see the particular interesting value in syntax, but I do understand its use as displayed. Few things to pick up from this. I didn't explain exactly how it duplicates yourself. If you ever use an in-game example, make sure you properly explain it and give full context to it. Again, you know why I might have accidentally skipped this, but I hope you get the full 2 weeks you're supposed to, and you don't make stupid mistakes like I did, and you can just fully elaborate this. Also, get someone to proofread, especially if you struggle like me. uh, where is it? Where is it? But I mean, this was fun. Uh, I was shocked that I put this in. I didn't even remember doing this. I want to say you should put this in, but realistically, it could come down to your teachers. Also, I am very proud of this, so I don't really feel like I should be encouraging theft of it. It was a lot of fun doing that. But no, that was no that's syntax, common sense thing. You will know syntax even if you don't know it by name. Things go in the order you give them. Wow, it's like when you did maths when you were a kid and you thought the order that you went through it was the correct one. Which wasn't true. It followed BidMass, but now that is true. It just follows the order you give it, and it's just as simple as that. There is nothing really else to syntax. You could probably use Bopper Battle for this example if you wanted to, because I didn't expand on this properly, on how and or why it duplicates yourself. So if you want to ever do what I didn't, you can go ahead and just take Bubble Battle. Declaration, initialization, and assignment. Declarations are used in tandem with Boolean true or false statements to set them as true or false. Assignment is simply assigning variables or a valuable or altering them in any way, frankly. And initializing is a prerequisite to activate a string, which could be the formerly mentioned true or false statements. I can't see that. And number values, but another example again could be as simple as a collision with another object, letting us fully define the context in which we want our code to activate, or put a value towards a variable which will be later used by a separate object. As shown, we can declare when a collision happens between two different objects, but register that happened so that the other object can use that information to initialize itself. So in order of events, declaration, assignment, initialize. A game that does this exceptionally is Little Inferno by Tomorrow Corporation, which initializes fire when you click, assigning that the value for fire being on is true. Then it could initialize any other feature specific to what you're burning seen on the image to the left, now being frozen as part of the mechanic for the snow globe object, therefore making declaration, initialization, and assignment an interactive and part of our game that keeps players engaged and invested in the gameplay loop as seen with the burn by repeat cycle in Little Inferno. By involving these scripting principles, we allow for a diverse and specialized set of mechanics for our games to follow, letting us push the boundaries of games. Developing the culture and setting new precedents is all that matters to me when it comes to art. For all the faults of a game, it's the ideas that makes it memorable or a classic that will forever be remembered. Which is why I hold these principles in such high regard. Without it, we won't have Little Infernos and the titles it inspired like open-ended sandboxes like Worldbox, or ones inspired by story like Thank Goodness You're Here. I think I got a little muddled up on this actually. I'm fairly sure, as you saw in the order of which I talked about gameplay mechanics, it goes initialization. I believed in declaration into assignment. If you ever wanna get it straight, ironed out, right order. But as long as you justify what they really do, also I believe this is wrong. What they really do, that you should be all good. I would recommend reading a paper on one of these, but just because I don't believe this statement to be particularly true, but I wouldn't call it wrong. Also, sad example again. Just the one here. You can use just anything that'll. You should no. What you should do is put one for declaration, initializing, and then assigning, and that will get all your bases covered and make sure you can get all the marks you need. Good example for the game though. Oh yep, Wellbox by Maxim Karpenko and Thank Goodness You're Here by Cool Supper. I like to credit things. That's why I have these big ass boxes in the top right. Arithmetical operators. Arithmetical operators are anything involving values that change its value whether by multiplication, division, addition, subtraction, and so on to achieve the desired value. These operations can also include more complex equations such as the use of con sin or square/rooting, and in the conversion/rounding of numbers/text. Just as in maths, we have an extensive need for arithmetic. For instance, we can use the formula involved in binomials and factorial over r factorial brackets n minus r close brackets factorial if we wanted to make an exponential equation for a variable, but without following the more linear route that normal squaring takes. However, as far as I'm aware, there is no way to use a factorial in stencil, as a less than statement can't fit inside a set value statement, so I can't force it to multiply with numbers less than itself and say negate floating numbers between the original value of the variable and 1. So in place, I offer the compound interest equation, which, as you can see, has correctly displayed the correct value of the total amount following the same equation. However, you may not be convinced by the practical application to this within games. So here are some examples of arithmetic operations in use. In the bottom left is the calculation used in idle spiral. That's the bottom right. Jesus, all right. By idle system inc. Used for the change in radius signified by the triangle of the spiral being equal to the sum of a, b, c, d, e times by q cubed plus k. Or as seen at the string at the bottom, we can use arithmetic to calculate a line between the player and enemy and push the enemy towards them. Yeah, as I said earlier, making a line, that's the radius, aka the simplest version of pathfinding. Another way of enemy movement would be random. However, a better choice, in my opinion, is to say when created, set a variable for starting y-axis, then take that away from the sign of x of self. So as it moves, it will achieve an up and down swing across the game. Voice is starting to hurt. Continuation. Never mind. I thought I could expand on that, but no. To conclude, arithmetic, ignoring my obvious bias, arithmetic is a very practical use in transforming or transferring data to something we can actually make use of within our games to make for more specialized inner power systems that can calculate appropriate values for our deeper mechanics, therefore being a much needed extension in our code that without our games would lack the boundless complexity and ingenuity behind that has developed infinitely longer, at least in comparison with its existence as game as an art within the culture of maths. You do not have to do all of this. Let me just say right now, you don't have to bring up binomials by no means. Fundamentally speaking, you want to bring up the stuff that is in stencil, obviously, right? So, core math, just arithmetic things you're already familiar with. At least I hope at this point. A good one here was sine. Mentioning sine is good. Sine is in stencil. You could use it if you wanted to. I don't know why you would. But sure, make use of it in your own way. Again, exponential ones. That's another good one to list. I'm drawing a blank on what the third slot for it was, but as long as you get this down and then maybe slightly more complex things like condensing or squaring, that should be all fine. It doesn't have to bring up equations, by the way, as long as they seem a remotely practical use. I mean, Idle Spiral is just kind of a dream game for practical use. This is just solely based on arithmetic. As you go in the game, it's actually got a more complex equation, which as I wrote this and I just had this on in the background, I later realized and I kind of regretted it because I could have used a really cool example, but I only got this basic one, which was a little sad and disheartening, but I digress. Talking about how the bottom part works is pretty simple. It's essentially saying, because if you've ever seen a sine graph, you'll know that it has a nice swing up and down, up and down to it. That wouldn't work here. Because it would be a 1 pixel change, I'm now realizing. And not a significant one. You would have to put something outside of the bracket to make it work properly, as you would hope it would. Just a negative or a positive, and you will see greater change. Maybe, but doesn't work as I would hope it would. But it does move your player at least. So, but arithmetic, yeah, pretty simple stuff. Oh, I didn't even know I did this. Oh, yeah, you could say this if you wanted to. I'm just trying to figure out how it works myself. I didn't actually playtest this code. Uh, no, oh wow, I'm reusing Go. Damn, that's my bad. Yeah, that works. This is another. Actually, this is a deeper use of syntax, which I did talk about. Has to be correct order, otherwise it won't work. And stencil doesn't have a like an internal logic system. So what that means is it won't follow the rules of bid mass. Essentially, you have to put it as a step-by-step process if you ever hope to put in an equation and have it give the correct answer. Otherwise, stencil will just start skipping steps, and that'll just give you the wrong answer. And that's obviously no good. So if you ever plan to put an equation, which would be nice, into your PowerPoint as proof, you have to say one of that. Again, don't need binomials. Don't put binomials in. This was not needed or necessary. It doesn't work. I thought I could make it work, and then halfway through writing it, I realized I didn't, and I just kept it in. Oh well. But yeah, you know arithmetic. We've gone up from the first grade to the second, you know. But here we go. Logical operators and ors and nots. Logical operators like and or and not act as logic gates, saying if and how a variable has or has not achieved a value or needs multiple correct values, then to cease slash the full function, which therefore lets the engine receive the correct statements for a string to function, letting them to act with full boundaries to surrounding context to make the right judgment, giving the correct gates are used, and so activate no errors or sub-optimizations in ideal situation, of course. Meaning logical operators are statements that allow allow for alternative information to be registered but not acted on if the circumstances are incorrect according to the same logical operators. Logical operators, as seen below, letters say that if weapon is not equal to 1, then none of the code will activate, but it won't start until the statement of space pressed has been achieved. We can use all statements if, per se, we wanted a separate win condition. One could be achieving the correct score. However, we can also set a variable of enemies and scene and then have enemies take away one from that when they die. That way, when the player steps into the door, the next level will start as long as one of these values have been achieved, which I took the liberty in making and showing as proof below. Among Us by Inner Sloth. As many win conditions, imposters can win by killing all crewmates. They can also win by sabotage, or if there are equal number of imposters as crewmates. It's not just win conditions though. Tasks like stopping reactor sabotage requires two players to be doing it, and statement as for a not. This could be when you take a medical example. I imagine the code is along the lines of if time is not equal to 0, complete is set to false. Continuation of logical operations. Realistically, then, we can simplify the use of logical operations to add a level of internal customization in our code, which sets stricter rules onto the player actions. The actions players can take as shown. This can force players into learning how the game is intended to be played, which is a strong tool that frankly has to be used sparingly, as in my opinion, having an open-ended system is far superior to a linear one. Yet despite this, logical operations again hold a lot of power, which maybe we shouldn't have. No one man should have all that power. Fun quote at the end. Uh, I'm fairly sure this is actually the incomplete version now, because some of these typos are truly horrendous. Yep, this is not. Is not. I didn't post the complete version apparently. But despite the typos, the horrendous punctuation, and the bad layout of all of this, we got a merit. It would have been a distinction otherwise, if it wasn't for obviously the faults just listed. So, you know, this is the playbook. This is the playbook. You know, close to greatness. If you can fix upon the mistakes that I have made, you should be getting that top score. Just whatever you do, please proofread. Oh my god, this is terrible. Where was it? R and okay. My voice is saying. Oh yeah, but logical operators, yes. not really you can say to that, is there? I mean, it's an and statement. You know how the word and, or, and not works. I really shouldn't be having to explain it. The only thing that is remotely tricky would be an or, and I think I've listed examples that I added in later, I believe. So, an or statement would be an or statement. Yeah, an or is just when something equals something or is equal to a different thing. It can have two different values that can exist at the same time, but will give the same result. That is all that an or is. If there might be any confusion with that, because and not is simple enough. It's just not something, and it's just another thing. An or, that might trip you up a little bit, but I think you should be able to understand it. This isn't, breaking new grounds here, is it? I'm also not sure on the legitimacy of what I'm showing. There might have been more examples. I know the whole thing is not done, so you'll have to figure that out for yourself. I will try to go off of what I do remember to help you out. But uh, good news, speed is done, and speed was a very tricky one. As simple as speed is, I feel it. I feel the need to go the extra step. Don't question me. Conditional statements slash the selection statements if else else if. Conditional statements like if slash else allow us to define the rules and space of our strings as they govern how they are activated by saying if or else. We make it so there are set parameters on how they should behave and what to do when the original statement has to check our code. This is to improve frame issues for players, as if all our statements followed when updating logic, you'll quickly find yourself needing to buy a supercomputer as your game tries to simulate thousands of lines of code constantly. If statements act as though the backbone to our game, something as simple as moving relies on if statements, checking that a certain prerequisite have been met for in the code of an object ensures that everything will be functionally normal. Functioning normally, yeah. Please don't touch anything by four quarters. Features many if statements by inferring from gameplay, as many buttons on your desk only open up once if other if statements have been fulfilled, like completing a puzzle somewhere else, but also has a different combination to the buttons in the image below. When you first click the button, a switch will appear as well as an arrow. If you click to the side of it and try to solve that puzzle, you'll end up with a completely different ending than if you click the button, which unlocks the button featuring Roman numerals and eventually gets you a screwdriver to unscrew part of your desk to access more buttons. Who would have guessed? This time colored. Yeah. These if slash else statements, therefore, not only act differently to logical operations, despite seemingly both placing restrictions within our game, but unlike logical operations, offer a more widespread use for mechanics and overall gameplay elements to take place within our games. Let me see the examples. Wait. Oh, just basic movement. Not only does this make conditional statements a better tool for us, at least in my eyes, as they allow for much more freedom within games, allowing players to explore and experiment, which helps push the envelope of our culture. Despite the seemingly primitive example, if a studio with a larger budget got a hand on such ideas, I have no doubt in my mind that they would innovate endlessly, not just given their first success, but transforming the same title to VR, which is an entirely new experience that once it becomes affordable will blow up the industry, as they would have access to a physical way to interact with players. Sorry, I keep stumbling my words. It's getting really hard to speak. Uh, but if and else statements, there's no example of an else or if statement here. You need that. Again, I don't know how much more clear I can make it. An example of an else statement is literally just if it's doing this. Otherwise, if it's not doing that, it will have to do this instead. Which can be, I wouldn't really recommend that with a one updating statement. You probably want to do that with something more finite that won't just constantly be happening, but it's really up to you and what you're doing. It's just otherwise you might start running into frame rate issues, as mentioned. But yeah, else it will just start doing that, and else if is the same thing except else with an if. Otherwise, it'll do this if that. Yeah, I think that technically follows an else if as well, because if not's doing this, it should be doing that. But all's well and good, it looks like. Uh, yeah, good example. Only bad thing is that I am struggling to read it apparently now. Looping iteration statements due for repeat. Loop statements are repeating statements that reenact the same lines of code, usually until reaching a set goal placed in terms of a variable. This can be do after slash every statement, as they reiterate after a set time, or the literal loop until statements found in stencil. They first will initialize our values, then pass through an if statement, finally changing the starting value of the variable or some other related one. Looping statements are often simplified versions of code, as we can set a true statement at the end of the loop, followed by a do after if true statement, then set back to false, and so the loop repeats itself. The loop has achieved the until slash while part of the statement. We can see a great example of loops in idle games below. I've made my own version of one that will increase the volume of cookies you have by grandmas multiplied by the output every second. In order to activate the loop, the conditions need to be fully activated to be fulfilled of actually having a granny and time being true. As long as they stay true, you always will be making cookies passively. This is a greater effect in the game like Eidolon by Lava Flame 2, mentioned earlier, Spaghetti Code Guy, as the auto attack mode will use the attacks in priority of arrangement to the hopper, and when they come on and off of cooldown, aka iteration, as you slowly progress through the game, your auto mode slowly gets more powerful until you're killing hundreds of mobs every few seconds. Using progress through the game, your auto whoa. Using iteration inside of games best has a building effect where it allows the players to get stronger over time, but still with the involvement. It could be argued that having an auto attack mode directly goes against the idea that looping statements are actually beneficial in player engagement, but I have always found these systems to be greatly gratifying. The snowball effect is a powerful one that I think all kinds of players will also be able to enjoy. It is then my belief that iterations make for interesting and satisfying gameplay mechanics, not only because of the snowball effect, but because it can be used for automation later on in the games to free space in the minds of players for more complex and deep mechanics. Without iterations, we wouldn't have the genres I've sunk thousands of hours into. Oops. To me, idle games are always a gateway of entry for future developers, simple enough to implement but tricky enough to make them think and use broad sources of code. Messing around with the arithmetic and functions of variables, meaning people have an easy access tool to get them into game development, something always good. Uh, Evaluation is also a strong point you should do. It's not just the analysis, neither. It's basically like writing, if you've done business, your standard line marker. You know, you have your points, you go through your analysis, and then you end off on a strong evaluation of the whole subject there. That would be the ideal answer with that. This is a good one. This brings up tastefully all of the things you probably should be bringing up. Things that do loop, practical uses of loops, and yeah, I don't think there's another way to explain that. I mean, obviously you have to come up with your own way to use a loop and iteration within your code, but there's a few things you can do with iteration. I'm personally doing something with a list right now that involves iteration, just looping a set number of times and going through the order of the list. But uh, yeah, looping. Oh, there is more. It is then my belief that iteration makes for interesting and satisfying gameplay mechanics, not only because I remember now. I think I was gonna cut this out and put it in the back. I don't know why it's not also here, and I can't find my mouse. All right, I'm blind now. Jump statements break and continue. Jump statements, as the name implies, is when progression of strings jump from one event to the next, following multiple logic gates to get a desired outcome. This could be when an unexpected collision happens or a set variable has been achieved elsewhere, which could cause the break in code. However, once the new event finishes, the normal of string codes continue with no issue. Therefore, jump statements help to control the final output of the code, which could be used to prevent bugs or game-breaking glitches, adding a layer of stability and control to our game. Also, by governing anything that comes up during the object's events. An example of this is when a player touches an enemy, knock them back, interrupting the player's movement in order to protect them from being hit repeatedly. Another is when the player comes into contact with the floor to swap the animation being displayed from freefall animation back to walking, again setting rules to adjust the balance of the game. Overcreation by multiple games has a feature that revolves around breakpoints. Spells you cast disrupt the normal string of code to gain a bonus of some sort, or when you consume a potion, again when you swap what you're researching. By assisting in core features that are in control of the overall feel of the game, breakpoints not only contribute to larger mechanics but mitigate possible sources for error or player boredom by quickly switching how the game handles itself with the player. Continuation of jump statements. At this point, I feel it's safe to say that jump statements are statements as proving are proof are important by providing that much needed difficulty scaling our games need. However, breaks are still limited in use. So yes, they may be easy to include in our games, at least stencil if occasionally tricky, but for all the pros of jump statements, I can't find myself all that excited by them. They don't have trend any particularly interesting. A new they don't tread yes tread any particularly interesting or new ground. In addition, they aren't necessarily a mandatory parameter you need to use in our games. I think I undermined the value of jump statements heavily. Apparently, a few people got the examples at least wrong within our class. I believe this is correct. I am not too sure this one is. I know this one definitely would hold. It is a breakpoint. Really, when you're thinking about jump statements, really focus in on the idea of it being a breaking point. It is a break in the chain, which is just completely something different in the occurrence that something else has happened, and then it leads to it, really. That would be the best advice I could give for making code for a breakpoint or a jump statement just for your own use. The knockback thing was a good one. This was just on my teacher source code, so this was just very nice and handy to have and put that in. So yeah, you can just get that and copy it down. That will work for you. But for the most part, it is true. This could have been expanded upon. I always struggle with the openers to these. I find it much more harder to define it without immediately going into the deeper analysis, because I think the definitions are much more boring and I think they are very simple to grasp, and I prefer the analysis. But undermined, I undermined it. It is a more potent and necessary part of the game you would imagine. I wouldn't say it is a necessity, but you will be using those most likely. Subroutines are smaller substrates of strings that make up a wider source of code. Inputs that from objects go into them are later recalled back on for the continuation of the string whenever the internal variables are needed again. What we are doing here is something called stack memory, where we take a variable, pass them through multiple subroutines to store the data, and for when we need to call back on them, these are the acts of construction and calling, building a stack of strings for our values to pass through, and later we will be calling back on them any number of reasons. Though it's important to note that the called value will be the last one used in the subroutine. Below my code is displaying this very principle. The data stored in cat is then called into the player. That way, you're moving in tandem with cat, so you won't fall off of it. Many games recall information like this to form gameplay, but the easiest to understand, at least for me, is in the Bit Bytes by Leo Cosson. As when a bit byte is created, its brain is created with set values, and from every action and everything it sees, the bit byte takes passes through the brain, going through the nodes and synapses, and finally can decide what the best thing to do would be, based on the internal values of the nodes and the synapses. We can from there infer a few things from subroutines, that they are a higher level of skill, requiring a lot of setup and thought to make possible, but also the limitations. They're too precise that in the end, in they're too precise that in the end it makes them predictable. Now that's all well and good in a simulation game like the Bit Bytes, but look at the enemy bosses in a game like Blasphemous. Great game, but the subroutines have become so recognizable in gaming, we call them attack patterns. So I argue, where's the fun in knowing what the enemy will do, or simply learning the subroutine itself? As finicky as subroutines can be to construct, they are very gratifying when in proper use. But as a tool for up and coming developers, I feel the gateway to entry may be too high. Yet, despite that, I am very interested in trying to use them more within code, as they still offer a great system of control. At any rate, though, I have my reservations about the internal specifics needed for subroutines. If used for strictly logic based operations, nothing should, in theory, go wrong, and so work just fine. This is how the Bit Bytes brain work. You don't need to know this. Uh, this is just how a subroutine would go through. It would go through thingy. This is a much this is a very good, I would say, representation visually for subroutines. It goes through here, comes past here, goes into the next one, and so on. The Bit Bytes brain is very nice. The Bit Bytes is a very interesting piece of code. But yeah. Subroutines, yeah, they are tricky. For this one, with the stacking, I read a paper on this. I believe it was by something geeks. If you literally type in on your computer, like, how do subroutines work or something like that, this should be the first result. The paper that I read, I have a bibliography. It's just I am not certain it is complete because this is a older version of my paper. It is not. Subroutine. It could be by the BBC. You should read both articles though, because they are both good articles. Here it is. Subroutine, nesting, and stack memory. Geeks for Geeks. There you go. It is there. Geeks for Geeks, by the way, is a great site if you're looking for any additional information on specific or more complex ideas of code. They were very great in the making of this. I have a lot to owe them. Finite state machine. Finite state machines or state diagrams are fully contextualized and pictured graphs, so to speak, of all the values a variable can take at any given point, focusing specifically on the state an object can take rather than any event within our code that may alter that same state, essentially serving as the maintenance to our object, keeping things running and updating our other strings with values that tell them what phase the current object is in. This can take the form of updating speed of object, friction, mass, and group collision boxes. State diagrams, therefore, are versatile but are complex, so can be tricky to set up. Here we can see that when ground isn't equal to 0, set friction as 0.2. Another we can do is rewrite the basic speed code to say if more than statement letting a character pass through a state diagram to change its animation state, thus display state diagrams and their function. For a real life example of this in gaming, we can turn to I Have No Mouth and I Must Scream, originally wrote by Hall and Ellison but made into a game by Night Dive Studios, a point and click adventure that changes state based upon where you click. At least I can only imagine so with my knowledge of game design, to then perform the action that is dictated by the finite state machine. As I'm aware, these actions should already be pre-registered within the code to save processing power, and are then only chosen once an outside occurrence passes through the state diagram, which then lets you walk to the next area or try to eat fruit. but failed due to bowel movements. That is a real thing. There he is right now, failing to eat fruit. Everyone laugh at him. All right. I'm on the edge with state diagrams, as on one hand they are relatively simple to set up and achieve the job well enough in the context of story-based games or something equally as linear, but I couldn't find myself coming up with any unique ideas to do with the concept and can't see myself practically speaking using them again. Though I must conclude that overall used to be more so beneficial than not, as they are capable of optimizing games by making the data at the ready for easy use. And today's sphere of modern games, there's nothing we could need more than optimization. My voice is actually going to die. Oh my god. This is a good point at the end here. You can just nick that one right off. That will do you some good, I would hope. It talks about the modern game space, and obviously the stupid 300 gigabytes that COD will take you to download. That's always a good one. Modern day examples are great. Always use examples when you're doing these. This is it. It just proves you have a knowledge of the subject, even if you don't know the full details of finite state machines. Which, by the way, if we come over here, the paper for it should be here. What is a finite state machine from whatis.com? There you go. That's probably where I got it from. If you wanted to actually read what that would be about. But yes, as I said back here, I think this was a good example. It's a pictured graph. There is just a bunch of data points plotted out on said graph, and then when something happens, it'll take that one and then promptly use it. I think that best describes it from what I can tell, but at the same time, I am not the most confident in this example. I don't have a lot of, I think even on the revised version, I didn't have a lot of ones on this. I mean, for some reason, oh no, that does make sense. I was looking at this. That does. But yeah, not a lot. Obviously, the value here is wrong. I got the value there wrong. I did change that later. Not too important. They have a tricky name, tricky function. I definitely recommend reading more than one paper on this if you want to do really well. Really just guarantee that distinction that you probably, hopefully, would want. I mean, I can't imagine why else someone would be watching this other than for shits and giggles. Regardless, fuzzy logic. Fuzzy logic is when we first fuzzify, so to speak, the initial values of our variables, processing them into uncertain numbers that later go through a rule base, which essentially is a series of if statements that transfer these variables into values which decide how much of a certain action should be taken. However, we still don't have complete values, so now they pass through an inference engine to evaluate the new data and to look to see what if statements would best fit the fuzzy number. Finally, the system reconverts the data back into complete values that our engine can now properly run without error, given everything else went well. An instance of fuzzy logic is given below. A circle is drawn around the mouse for indication, and when the radius of the 2 points is less than 5, therefore inside the circle, set proximity to true. When proximity is true, it will start to push the player towards the mouse. The other updating statement of significance simply states that when player is outside the circle, set proximity to false. This is only fuzzy as we're using more than statements and are taking coordinates. Our version of an inference engine here would be setting the hypotenuse between the 2 points to an absolute value, after which can finally be determined if the player should be sucked into the mouse. Continuation of fuzzy logic. Proceeding forward through, we can see greater use of fuzzy logic in a game like Jacksmith by Flipline Studios, which, using deduction, uses fuzzy logic to grade the quality of your weapon, allowing for that internal data to again be transformed into gameplay. Having player feedback is good for the achiever type of player, but deeper than that, the quality of your weapon also decides its durability and damage output, a double-edged blade, if you will. I find fuzzy logic a lot more intriguing and stand to gain a lot by fully learning the full extent that fuzzy logic can be pushed to, but I digress. Fuzzy logic therefore can make for key features and interesting design choices, as its versatility and countless scenarios it could seamlessly fit right into is staggering. There's nothing more important in culture than innovation, and I believe I've proven that it's capable of pushing the boundary forward by turning quantitative data into something more similar to qualitative values. Uh, Business terms here, don't question that. Simple stuff. Just quantity, quality. Simple enough. Where is it? There are certain points here I want to pick out. Here, sucked into, it acts as a whirlpool. This is backwards on purpose, so that you will be drawn into the circle instead of not. Which is you're just your mouse in this case. There's your mouse is the little whirlpool that sucks up the player or whatever, and then yeah, fuzzy. Fuzzy, you can fuzzify in a lot of ways. If we're being honest, I don't think I specifically stated why it was fuzzy. I know I said use more than statements, but it's fuzzy because it can have a lot of values. For example, it says with the radius of 5 is the circle, right? But it can have any value that lie in the circle of 5, which can take many different points, as you might have guessed. But also the value for x and y change. So realistically, that could have any value to it. That could be anywhere on your map of the game, and you would never be able to know. And that's why it's fuzzy, it's not very certain, but we make it certain by using these statements here, which act as the, what was it, inference engine, yeah, turning it back into strict code that will push us into the mouse. Yeah, that's it. There's many ways to go about this. I am working on another one right now, so I don't actually have an example for another way you can do this. I was given this by a teacher. In a technical sense, I transformed it into this. And so from there, you can probably accidentally reverse engineer what the teacher did just by taking this and thinking about it for a bit and then making your own thing. And then somehow we've gotten like this the same project again, which I think would be quite funny. But maybe your teacher gave you something like this, and then from there you can make your own little way of it. Maybe it'll be the enemy that's moving around and not the mouse. You can do this in a lot of ways, and you don't have to do it like this. This was just the example I was given. You can turn things into fuzzy logic. Uh, I usually prefer to use proximity-based things like circle points, but you can make them go through the fussification process even further, and then you can give a, like we saw for Jack Smith, quantitative value for those data points once you pass them back through the inference engine. Yeah. Pathfinding and navigation. Pathfinding and navigation is when our objects judge the distance between themselves and another point, then taking the most optimized route according to internal values. We can achieve this with a basic formula like push towards player X, take away enemy X, and the enemy will start to move towards the player. A more traditional method of navigation would be hierarchical pathfinding, where the map is sectioned off into clusters. These clusters are preloaded, meaning they are safe in processing power, as the point from the object is already able to navigate the best path possible, as the distance for adjacent clusters to and the end point of entry has been measured, and so knows where to go. Uh, I basically got this from the wiki. All of my points were developed like from the wiki of pathfinding, I believe it was called. That or navigation. Search both of them up. One of them will be about ships, and that's obviously not right. One of them will literally have like use, I think it's pathfinding like in games, and then you go there and it will talk about hierarchical stuff if you want to do more info about that. But it's a really simple concept. It's just how does this get from point A to point B, really? I feel like it's artificial intelligence. So what you don't want to bring up right now is player input. Don't say things like player speed when they're touching, like the right arrow or whatever. Don't do that because it's talking about artificial intelligence. It has to be a logic based way of moving. Which could even be illogical realistically, but I would recommend you strictly speaking to logic since it's talking about the way that it pathfinds and navigates. Obviously you have this way. Hierarchical, as I mentioned, you can like section like the whole map off into a grid. I can't do that. I don't know how to do that on stencil. Uh, and then it just knows from there the points at which that grid is and the quickest way to get through those grids to the player. I assume so. I used Rimworld as an example. It's a great example for pathfinding. It's amazing for that because all of them are just moving around constantly. Going back to Oni from earlier, that's also the same thing. Basically, like any colony management game has good pathfinding and navigation because that's just how the game's meant to be done. It's meant for maximum optimizing. That's kind of the fun of those colony management games. So any one of those will get you a great answer. I'm sure of it. My voice is gonna die soon. All right. 2D physics engines. Stencil, our 2D physics engine, transforms our blocks into actual code that the engine will try to run and simulate. Being 2D just means all internal objects will in turn have to be two-dimensional compared to an engine like Unity or Unreal where they can be 3D. 2D engines like Scratch are obviously limited by a whole dimension, but in return it offers a much more accessible system of using blocks to simulate code instead of having to learn something like Python to code. More than more than dimension, though, the processing power is far weaker than something like the Fox engine by Konami, meaning you can have highly complex code, but you have to spend a lot more time optimizing it so Stencil can actually run it. Uh, you could actually add examples to this. I didn't, even in my final one, but backgrounds in Stencil take up like nearly megabytes of like just footage in the game, and that is just shocking for Stencil. You hear megabyte, and you think, oh, that's not a lot, but like think about it. Normal like scene backgrounds will be like 13 kilobytes, and you've like 50x that. You have well exceeded what you really should be spending on processing power for scenes. Backgrounds, I mean. That's why they tell you not to put backgrounds in. I personally put backgrounds in only because I'm making a text based game, so I'm not relying on actors really. I'm drawing boxes and saying points from here to here. If you know about mass inequalities, that's basically what that is to define a region. But yeah, collision detection and then resolution. Didn't write this one, but I can talk about it. Collision detection is, collision detection. It's saying when actor collides with so and so, something will happen, and that would be the resolution part of the thingy. Going back to the example we used earlier, of like when the player hits enemy, it will bounce off of it, right? That's the breakpoints one we mentioned. Yeah, that is it. It detected it. It resolved it by pushing away. Simple as, resolution could even mean like an inaction, really. I mean, you could say when it collides with a tile, you won't move up that tile magically, you just stop there. And that's the resolution. You just stop movement speed. You just lose all your velocity, and that's the resolution. That's the collision at that point, and then resolution, no more speed. You don't get to move anymore. Take up a lot more things right now. I'm just running on like 3 FPS apparently. Voice is killing. I didn't know one of these would be so hard. Damn. Collision detect. What? Collision detection. Collisions. Collisions could also be with regions. That would be a good example to bring up. Regions have a good way of resolving things. Usually, you can just put like death pits there for regions, and a lot of other things like scene transitioning for regions, secret areas, which is fun. That's another way you can resolve it. It doesn't strictly have to be within objects or actors. It can also be regions too. But yeah, rigid body. Rigid body is simple. Rigid body is it doesn't fold or bend to whatever it collides with. It stays the same shape no matter what. No matter what happens to that actor, its physical shape will stay the same. It won't change. That's all that means. Dynamics don't confuse it. It just means it's rigid in structure, literally. If you know what does it say? Like in physics, I think it is rigid in structure. Yeah, yeah, rigid in structure. That yeah, it's the same thing from physics. There, particle simulation. Particle simulation is when we simulate lots of smaller objects, typically in three stages: an emission stage, where the object is deciding whether or not to create a copy of an object, leading to the next phase of simulation, which just decides when and how the particles will spawn and for how long they'll stay. Lastly, the objects are finally being processed through sensor visually, hopefully giving the desired effect. Particle simulation could add smaller details to our game or of other entirely new features such as with an enemy attack. This is what that could look like as shown below. We're saying if the enemy attack has created a dust particle that will look randomly across the screen. If we wanted to make it do damage, we can also add that when touching player, set HP to -1, then kill self. Didn't write a lot on that. Source, wiki. This is the wiki. Again, it's not hard to research these things. You really should go out your way to, because it's just the first result. It's just the first result. There was, I don't know how. There was literally, it's called particle simulation. This is just a wiki on particle simulation, and it was such an easy article to read through. Like you just skim through it, you pick out stages. All right, it's sectioned off so nicely. There's no excuse to not do this research. It'll take you like 10 minutes, maybe. I want to say it doesn't take very long at all. And it's just very easy to make. Yeah, that's just particle simulation. It's creating lots of mini actors, like the instances that we brought up earlier. And I mean, that can just be used for collision detection mainly, honestly. It's just, it can just decide an area or a spot on which it saw a player at. Just detection kind of thing. I mean, there's not really much else to that. And if there is, you can read it back by yourself, because I am done with this. Mass of the player. You should know mass by now if you took physics. Mass of the player is literally the downward force of it, essentially speaking. It's just how much it weighs. You know, if you have gravity set on, which you should for your game, probably, you will see higher mass objects move down frequently. Higher mass objects are harder to push, as it mentions. They have a lot more trouble with speed. They follow the same rules of mass that you would expect from real life. You can call it weight if that helps you simplify it, but you know, I did too. There it is. Simple. Simple as. This is the big one. This is the last one, I'm pretty sure, as well, so you can have a fucking field day with this one. Velocity simply measures the rate at which your character is moving. Though slightly different from speed, as velocity also has a direction, not just how fast you're moving. Acceleration is simply the force acting on the object so that it can reach terminal velocity. By offering freedom of movement, it allows our player for independent thinking. We don't have to stick to a linear sort of gameplay. In Mario, we can make speed exponential if we so choose. Titanfall 2 uses speed to great effect, though occasionally unintentionally due to bugs, but it works, delivering an amazing sense of adrenaline as you zoom across the map. Was that? Wait. Okay, there we go. On the previous slide is an example of an alternative way to control player speed. More exponential. There's a lot of moving pieces, so I'll break it down to its necessities. A speed is set to variable speed. Variable C divides speed to get the value for power. These variables come back up in the actual movement string, with slowly decreasing in value and power multiplying with speed. Power will only multiply if positive/negative, dependent on direction. Certain variables have more/less statements there, so the values can reset and the speed doesn't go ridiculously high. Tests have shown it reaching infinity, which was a fucking gut-busting experience when I was playtesting. I was beyond baffled, but there you go. Another game with a great sense of speed and scale is Sonic Mania, taking the original style of the Sonic games and improving it on it with new ideas, design choices. Oh yeah, Sonic Mania by Sega. It doesn't say it there. I forgot to put it on this version apparently. Design choices and level layouts. However, it can be said that satisfying feeling of speed comes from the level design. more than any code involving speed, but in my opinion, the momentum Sonic carries and the initial acceleration, but much faster acceleration with a spin dash, more than carries the overall fun of the game. As important as the level design is, I think it's safe to say that speed is a great way of providing satisfying and frankly addictive gameplay. This is an amazing example. I was given a what do you call it? Example of this, I want to say. Well, I think my friend was. No, I was too. Yeah, we were given an example of this. I have heavily rewrote this. I initially wanted to make an exponential. That didn't work out for a lot of reasons that I won't bore you with. But no, yeah, it works. If you wanted to make an exponential work, positive values would have to follow even exponential numbers, and what do you call it? Negative values have to follow odd exponential numbers if you wanted to really make it exponential. Though, as I said, where is it? Tends towards infinity. There you go. This is a great example of speed. You can have a normal one, but something more complex like this is always fun. This is essentially like a rocket jet, as you hold down the button more, since the c, the constant term, divides into power and gives you a lower and lower number, as shown here. Your speed will just keep growing at the rate of which it can possibly grow. And obviously, these just cap out the speed. If you increase this to 300, you would see max speed be 300. Oh no, that's when release as well. Yeah, no, it doesn't cap it out. If you did want to cap it out, you'd have to say we're holding it down though. Just to go back to some points here that you might not. Oh, yeah, I thought we skipped soft body physics. Soft body physics, opposite of rigid body physics. It's the actor can just bend and mold itself around it. You wouldn't really see this on 2D games like ever, because it's just kind of unheard of. You can almost, I don't think you could get away with this. I think someone else in my class tried this and they didn't get away with it, but you possibly could get away with growing and shrinking. I think for this one though, you do actually have to use a 3D example. 34A isn't really too clear on whether it wants you to use 3D or 2D examples. Make sure you ask your teacher about this one. Just to be very clear on it, some might not. Not too sure on the details of it. So yeah, soft body, body or body, it can just bend. It's moldable. It's just shapeable. Uh, you can for rigid body physics. If you want to use an example of it, I would say like if you go to your properties or whatever, I think it's called physics, properties of physics of an actor, you can say like cannot move, and I think that would summarize rigid body quite nicely. Uh, Soft body, as mentioned, mass. Mass doesn't have a lot. You can, if you really wanted to use examples, just show images of mass, and then this blocks instance, so that can say like change mass and stuff, and that should just cover it. There's not a lot you can really work with there. Physics is just an easy one to knock out with. Uh, these are some good links. You should use a lot more research though. Apparently, I used one for iteration and didn't even know about that. But there we go. Somewhere here, there should be. No, there isn't. I can't show you the notes I got or the grade, but they had a lot of very pleasant feedback. A lot of praise, and just telling me to touch up on formatting. That's where I got. That's why I lost my marks. Not saying you should, but if you were to copy this one for one, word to the wise, fix this fucking formatting. I think that actually lost me the distinction there, which is very disheartening. But at the end of the day, wasn't charming apparently. Although, according to my teacher, it was fun to read. So when you put in stupid shit like, where is it? Where is syntax? As dictates logic makes order are proper sentences, therefore which without wouldn't. it's very fun. I think. But that's another example. If you haven't wrote something like this before, make sure it's enjoyable to read through. That you would actually want to read through this. I hope that it was engaging enough for people to listen to here. But you could just be here to get a nice grade. A merit at least is always nice. Uh, but yeah, it fix up the formatting. Honestly, you probably didn't have to put these logos in everywhere like I did. I just like crediting things. That's my little thing. Drop me the fucking distinction though. But that's essentially it for 34A. You don't really. There won't be a video for 34B. 34B is just your own thing. These are much more, I guess I would say, objective in a sense than 34B. 34B, you just make your own game. I don't need to help you make your own game. You can do that yourself. That's it, basically. If you want to know how to get a merit, feel free.